radicals. Now, the first step in general is to isolate the radicals. Isolate the radical if there is one, but if there's multiple, the only way to isolate is going to be to eventually square. The point is there any algebraic manipulation you can do right now that's really going to help you before squaring? No. You theoretically could divide by 3, but then you're just going to create a 2/3 or 2. But should you create fractions if you don't have to? No. So at this point, what should you do? Square both sides. Square both sides. So if you square both sides, it's really important to me that you actually write in like parentheses or brackets with the squares in the right place. You can't just parenthesize the entire line. So if you square this, can someone raise their hand and tell me what the left side becomes? Hannah.
9
times.
x-1.
Yeah, and Sarah, what does the right become? You got it, yep.
No, 4.
Yep.
Parentheses 2x plus 2.
Is it really important that you put those parentheses around those? Yeah, it's really important.
That's
so
different than what I thought it was going to be. I thought it was going to be...
Well, no, think about it this way. If I have two things and I'm squaring this, what does that mean? That means AB times what?
AB?
AB. And at this point, the parentheses...
So you just skipped a step.
A, B, B. So what is that? A squared, B squared. It's the same thing over here.
Oh, so you just kind of...
Kinda, yeah. Yeah.
Of, like, writing it off.
3 squared, that squared. Yes, exactly.
Okay.
So now, one word. What do we do next? One word. Distribute. Says Chris with such passion. Distribute. Okay. 9x minus 9 is equal to what?
8x.
Plus 8. Subtract 8x and you get 8. You get x minus 9 is equal to 8. So x is equal to? 9 plus 8 is? 17. What should you do at this point? You really, really, really should check. I love it when you write the word check and then go through it carefully with that question mark above the equal signs. So you have 3 times the square root of 17 minus 1. Does that equal 2 times the square root of, what's 2 times 17? 34 plus 2. So that's 3 times the square root of 16. And that's 2 times the square root of? So that's 2 times 4. Does the 3, thank you, does that equal, see, does it equal 2 times 6? Does 12 equal 12? Yeah, so does it check? Yes, checks. I know it's kind of frustrating and that some of the examples we've done, it feels like you're doing nothing because you do a lot of work to prove that there are no solutions. That in itself is an important proof. Remember what I presented in chapel last week? The hardest question in the world was not a proof of existence, it was a proof of non-existence. It was a proof that something didn't exist. And that's work sometimes. There's a kind of proof methodology called proof by contradiction, which is really fun, which is you make an assumption, and then you prove that if that assumption is true, something that is obviously not true is true. So for example, if I say A equals B, let's say I assume A equals B. This is my favorite proof method. Let's say we assume A equals B. We do a lot of true math, and at the end we come up with 12 equals 15. Is this true?
No.
So what does that mean about the assumption? The assumption isn't true. So one way to prove that A doesn't equal B is to assume it's true and then show that reality would cease to exist if it was equal. That's a hyperbolic amplification, but that's something. It's called proof by contradiction. It's my most favorite proof methodology. I loved it because it meant you were just searching for a contradiction. It's really fun. Doesn't mean it's easy to find? No. Another, you have two radicals equal to each other. Is there any sort of isolation or simplification that can be done right now? No. So what do we do to both sides? You cube both sides. Exactly. To get rid of a square root, you square both sides. To get rid of a cube root, you cube both sides. Sorry. So if you cube a cube root, what are you left with? Just the thing. So what are you left with now on the left? Plus 5 is equal to? Subtract 2x, you get 5 is equal to 4x plus 1. So 4 is equal to 4x, so x is equal to? 1.
Yeah, I was looking at a different problem.
Oh, okay. I was like, I don't, please don't cube things unless you have to. It's kind of like don't create fractions if you don't have to. Don't multiply out horrible things unless you absolutely have to. It's a rule that will stay with you. In calculus, sometimes we work on these really high-powered functions, and sometimes the kids are tempted to like multiply it out because it's correct. Like they're not doing something that's wrong, but do they need to do that? No. What should we do at this point? Check. If we check this, is the cube root of 2 plus 5, does that equal the cube root of 6 plus 1? Yes. So does it check? It checks. Yay. Yes, go ahead. That's slightly more complex about this one. What's slightly more complex about this one? Yeah.
You have to multiply x plus 3
times x plus 3. You square both sides. It's really important that you square both sides. The radical is isolated. I think you weren't here for this, but we did this one in class, I think. When you square this, you end up with 9 minus x is equal to x plus 3 times.
X plus 3.
So you have 9 minus x is equal to x squared plus, yeah, 3x. I'm just going to do one more step, plus 9. So 9 minus x is equal to x squared plus 6x plus 9. What type of equation is this? This is a quadratic. So what's the first target? You're going to end up factoring, but first you need to do what? Exactly. So let's cancel what we can. What cancels on both sides immediately? The 9's cancel, right?
Yeah.
And then what can you add to both sides?
X.
Plus x. So what do you end up with? 0 equals x squared plus.
7.
What can you factor out of that? So you get 0 equals x times x plus 7. So you have two things that multiply together. The zero product property, do you remember this?
Kind of.
I didn't really, your product property says
Oh yeah. But
if a times b is equal to 0, then what? A or b or both, what? Equals 0. So over here, what does that mean? X equals 0 or what? X plus 7 equals 0, which means x equals. So there's two possible answers. These are only what? Possible solutions. What do you have to do?
Check.
You have to check. So if we take this, let's check 1 here. So let's check x equals 0. It's the square root of 9 minus 0. Does that equal 0 plus 3?
Yeah.
Well, does the square root of 9, does that equal 3? 3 does equal 3, so yes, it does. But what about x equals negative 7? The square root of 9 minus negative 7, does that equal negative 7 plus 3? So it's a square root of what on the left? 16. Does that equal negative 4?
No.
4 does not equal negative 4. So this one is the only, this one checks. This one is not a solution. Does that make sense?
Yeah.
Remember though, kids, you need to understand these methods because this method right here is the cleanest method and you have to do something almost identical to this in order to earn for full credit. Just knowing the answer on this is not enough. Is not enough. Yes?
Are we going to eventually?
Methods that I haven't taught you yet. Like there are simple cubics you can do where it's like x cubed plus x squared plus x. And you're like, okay, that's x times x squared plus x plus 1. And then maybe you can factor this with the quadratic maybe. But the point is, you don't know how to do general cubics. Factoring all cubics, hard. Not what we're doing. Any other questions from the homework? Is that 2 underneath the radical?
No.
So where should you move it? Other side. So you get the 4th root of 8z minus 3 is equal to? What do we do to both sides? Fourth what? Fourth power. Fourth power. We raise it to the 4th power. So if we raise it to the 4th power, what happens to the left side? Correct. So you're left with what? 8z minus. What's negative 2 to the 4th power? Negative 2 times negative. Is it going to be positive or negative? It's going to be positive because it's an even power. It's going to be positive what?
16.
So you get 8z minus 3. So what do you do to both sides? Add what?
Add 3.
Equals 19. So z is equal to?
9 over 8.
19 over 8. 19 over 8. Now what do you have to do at this point? I know it seems annoying because it's a fraction. It's not that bad to check. So you have the 4th root of 8 times 19 over 8 minus 3 plus 2. Does that equal 0? Well, what happens to the 8's here? They what? So that's the 4th root of 19 minus 3 plus 2. Does that equal 0? Well, that's the 4th root of what? 16. 4th root of 16. Does that equal 0? What's the 4th root of 16?
2.
Does 2 plus 2 equal 0?
4 does not.
So guess what?
No solution.
But in order to get full credit on this, you would have to first get 19 over 8 and then show that it isn't a solution. A way to think about this is the following. This is a 4th root, right? So this has to be positive or 0. It has to be positive or 0. If you add something that's positive or 0, that's positive, can you ever get 0?
Do you have to check it?
Let me finish my sentence. Can you add two things together that aren't negative or 0 to get 0?
No.
No, you can't. So that's why it logically makes sense, but that's not enough. You have to prove that it can't be proven. Yes, Gabby. What do you have to do to both sides? There's only one thing you can do at this point. You have to square both sides. So if you square both sides, what happens to the outer square roots? So what does the left side become?
2 in parentheses x plus 11.
And what does the right become? What's the right become? 4x plus 2. We can nicely simplify this before we square again. What can we divide by?
2.
If we divide everything by 2, what are we left with on the left?
X plus 11.
The square root of x plus 11 equals.
2x plus 1.
Now what do we do to both sides? Says Chris Espinal with so much emotion. We square both sides. What does the left side become?
4x.
X plus 11. What does the right become?
Sorry, the right side is 4x squared.
Remember, it's 2x plus 1 times,
2x plus 1.
and that's 4x squared plus 2x plus 2x plus what? Simplify, you get x plus 11 equals 4x squared plus 4x plus 1. What type of equation do we have? Yeah, good job, Sarah. Quadratic. So what do we set it equal to? We want it to be equal to 0, so we need to clean this up a little bit. We need to clean it up just a little bit. It's not that bad. What should we subtract from both sides?
X and then 11.
Yeah, let's subtract x and subtract 11. Subtract x, subtract 11, and you end up with 0 equals what?
4x squared.
Yep.
Plus
Minus 10. Now at this point, you have to do what? What's the one word for what you have to do? Begins with an F.
factor.
You have to factor this, and you are kind of dismayed, but it's not insurmountable. What's the one aspect of this quadratic that makes it so the factoring is a little more challenging?
4.
The 4. It's not 1, right? So you have to test these out. So you're looking for the leading coefficients have to multiply together to get 4. So what two numbers do you want to choose first?
2 and 2.
So let's try 2 and 2. The other two numbers have to multiply together to get what?
Negative 10.
So it's going to be 2x and 2x, and this is negative and this is positive, so we know it has to be a negative and a positive. So it multiplies together to get negative 10. Anybody want to pick something to try?
Plus 5 minus 2.
Plus 5 minus 2. You just test them. You just test. So let's test it and see what happens. What's 2x times 2x? 4x squared minus 4x plus 10x minus 10. So what do we end up with? Do we end up with what we want? No. So do we erase this? No, we test again. So we could do 2x. There's another thing we could test. What is it? Minus what?
Minus 5 plus
Minus 5 and? Let's try that and see what happens. What do we end up with? 4x squared plus 4x minus 10x minus 10. What do we end up with? Do we end up with the right thing? We end up with kind of the same thing, except it's negative now. Is that what we wanted?
We have to use 4x.
So now the thing we have to change, you're absolutely right, Noah. You notice how I didn't erase any of that? Why is it really important not to erase it?
Might test something twice.
Yeah, I've seen it happen so many times. Kids erase, 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 and they're like, it's not factorable. And it's just because they haven't kept track of what they're doing. So instead, let's test 4x and what?
1x.
And 1x. And let's multiply together to get negative 10. So what do we want to test?
2 and 5.
Not 2 and 5, you need to test. One of them has to be negative, right?
Oh, yeah.
So how about negative 2 and? Does this look like it's going to work? Why does it all of a sudden doesn't look like it's going to work?
Because the 4x
Yeah, that's-
multiplying by 5.
That's too big, right? So let's try something else. 4x and x, and how about what? Plus 5 and minus 2. What's this going to become? 4x squared minus 8x plus what? 5x minus. Is this closer?
Yeah, oh, you need
Is it almost there?
Yeah.
What's the only thing?
You need to flip the sign.
Ah, so on the 5th try, what did we get? 4x, what do we want? Minus 5, x plus 2, and what does this come out to be?
Correct.
The correct one. Does this match?
Yeah.
Hey, and when we find that, we are really happy. So you don't erase, you check. So what does that mean? It means that 0 equals our factored form. What is it? 4x minus 5 times what? X plus 2. And what does the zero product property tell us about this? 4
4x minus 5 must be
equals 0, or
x plus 2.
exactly. So 4x equals 5, or x equals what?
Oh, no.
5. I'm just bouncing back and forth, sorry. So there are 2 here. What are these called now? Possible solutions. And what do you have to do at this point?
Check.
You have to check them. I'm not going to check them. You've done enough checking. Are you confident that you can check? I really like it when you use the equal sign and the question mark. I love that. Use the equal sign and the question mark. Are they equal? Are they equal? Oh, look, they are. Therefore, it checks. For example, here's something you can answer. If I said x squared is equal to 4, what are the 2 solutions to that?
Negative 2
X equals 2 or x equals negative 2. Why? Because 2 squared is 4 and negative 2 squared is 4. Let's change it up a little bit though. Let's say I asked you x squared is equal to negative 4. So far, I've told you when you're given something like that, what's the way to state the answer to me asking what are the solutions? You would say what? Generally speaking, up until this point, you've said either no solutions, or a slightly better way would be to say there are no real solutions. I've mentioned that before, but up until now, that's been the okay response. The thing is, there are other types of numbers out there. There are other types of numbers out there, David. So what we are going to do is define a specific unit. This is what's really important, and I need you to stare at this for 30 seconds without talking. Take a look. It's really important. It really centers around this. The square root of a table is a table. So it doesn't matter what's underneath. If you square it, it's just whatever is underneath. So this is the unit that you need to memorize right here. I is going to be defined as the square root of negative 1. So therefore, if the square root of a table squared is a table, what does that mean if you have the square root of negative 1 squared? What does that equal? Negative 1. That's the first thing you need to remember. That's the first thing you need to remember. So why does this help us? Well, let's talk about that exact same question I asked you before, which was this. X squared is equal to negative 4. If you want to isolate x, what would you do to both sides? You square root both sides, correct? So if you square root both sides, you're looking at this. And you're like, okay, before you would have been all frowny face right here, right? Well, we're going to turn that frown upside down, yay. What's the square root of x squared? What does the left side become? That's nice, and you're okay with that. What we're going to do here is write this as the square root of 4 times the square root of, what's 4 times negative 1? 4 times negative 1 is negative 4. So are we okay with this step right here? Are we okay with this? What is the square root of negative 1? What are we calling that? I. We are now labeling this. This has a name. It's called I. It's not to the I power, but that is I. So this right here becomes I. So x is equal to the square root of 4 times what? I. What is the square root of 4? When you take the square root, what is it? 2 or? Negative. So x is equal to 2i, or x is equal to? Negative 2i. Let's check those answers. What's 2i squared? We're checking now. When you square something, what does that mean? Multiply by itself. What's 2 times 2? 4. What's I? What's anything times itself? It's squared, right? So I times I is I what? I squared. But what is I squared? 4 times negative 1. Oh, so does that equal negative 4? It does.
Even if because I squared is negative 1.
The definition here, what is I squared? Look at the definition. What is I squared? That's what I squared is negative 1, right? Okay, so we're just checking this. Let's check the other one. What about negative 2i squared? Squaring means negative 2i times 2i. So that's negative 2 squared and I squared. What's negative 2 squared? 4. And what's I squared? So what's that? Do they both check?
Yeah.
They do. So effectively what this does is it allows you to factor out that negative 1. If you factor out a negative 1 from a negative number, you're always left with a positive number. And do you know how to attack positive roots and radicals? Yeah. Hannah.
Wait, so is I 1?
No, I is the square root of negative 1. That's the definition right there. That's what it is. You have to really get that real set right here. Gabby.
What about the cube root?
Cube roots are not, let's just do this piece by piece, okay?
Okay.
So let's take a look at these. So what does this mean right here? The square root of negative 3 times the square root of negative 7. Let's talk about one way to do it. Since it's the square root times the square root, what does that equal? The square root of negative 3 times what? Negative 7. So that's the square root of. And we can't really simplify that, right? What's another way to look at this? Well, another way. Here's another way to do the same thing. This negative 3. Can you factor negative 3? Yeah, it's the square root of 3 times the square root of the square root of 7 times the square root of. So let's group these together. What is that? The square root of 21. And what's the square root of negative 1 squared?
I squared.
Negative 1.
It's just 1 plus 1 times
Is it negative 1?
No, because negative 1 says negative 1 is 1.
But I thought that would give you.
It's just negative 1.
Or minus the square root. Oh, it's plus or minus 3i. So what I want to emphasize here, this right here, we use the product rule. You cannot use the product rule on negative numbers underneath the radical. So which of the two answers is correct? If you can't use this, which one is the answer going to be? Don't use this. It's this one right here. What I mean by that is every time you see the square root of negative a, that's equal to I times the square root of a. You can turn it positive by putting I out front. Okay? So this one right here, you see this one?
Yeah.
How are we going to do that one? That's I root 2 times I root 8. So that's I squared root 16. What is I squared? Negative 1. And what's the square root of 16? 4. So this is negative 4.
Okay.
Not positive 4.
Wait, what is the? Oh, never mind.
The square root of negative 2 is the square root of negative 1 times the square root of 2. The square root of negative 8 is the square root of negative 1 times the square root of 8. What is the square root of negative 1? I. What is the square root of negative 1? I. I times I is what? Root 2 times root 8 is root 16. What is I squared? Negative 1. What's the square root of 16? What's 4 times negative 1? Negative 4.
I just have like a question.
Yes.
So we should like
Over the... Why are we allowed to multiply this?
form of 1.
Form of 1. Exactly. So what does the bottom become? The bottom's the easy one. What's the bottom become? Becomes negative 3 because the square root of a table times the square root of a table is square root of negative 3. Square root of negative 3 is negative 3. But on top, can you multiply the negative 3 times the negative 75? No, I said you can't use the product rule. Instead, you turn it into I root 75 times I root. How many i's do you see on top?
2.
And they're being multiplied, so it's I what?
Square.
Squared. The square root of, what's 3 times 75?
225.
Thank you. Over what?
Negative.
But what is I squared?
Negative 1.
So it's negative 1 times the square root of 225 all over. What cancels? What's an easy thing that cancels? The negatives cancel. The negative goes away. So then you're almost done. You're so close to being done. What's the one last thing you have to do?
Square root of 225.
Yeah, you have to somehow break down the square root of 225. What's, you can pull out 25 and 25 and what? 9. Hey, what are both of those?
Square roots.
That's the square root of 25, square root of 9 over.
3.
What's the square root of 25?
5.
What's the square root of 9? Oh, what is 15 squared, everybody? 25. All over.
3.
And what are you left with? This right here is just a fancy way of writing the number. Pretty cool, huh?
Yeah.
Pretty cool. Do you have to take these careful? Real careful? Yeah, you have to take it real careful. Real careful. This, I could say 7 plus 2i. That right there is called an imaginary, that's called a complex number. It's a complex number. What type of complex number is it? Why is it imaginary?
It has 2 I.
It has an I in it, exactly. So what do you get when you add the imaginary numbers and the real numbers together? Nope.
Complex.
The whole set is called that name. I just put it up there. This whole set right here is called the complex numbers. So it breaks down like this. The whole big set is complex numbers. One side is the real numbers. One side is the imaginary numbers. Do we have lots of different sets inside the real numbers?
Yeah.
Yes, we do. So the idea is the bigger set of numbers all look like this. A plus BI. And it sounds like it's going to make things a lot harder. Guess what? You'll love this because it's really straightforward. You treat I just like you treat any variable. The math doesn't change. What's I times I? I squared. What's I times I times I? I cubed. So for example, if I add A here, what's 2 plus 6?
2 times
8. Good. What's 3i plus 4i?
7.
Done.
Oh, we're not multiplying anymore. Right?
No! What's that right there?
Addition. I was like, what is?
Will we multiply? Sure, but what does that say? Adding, okay? What's 4 plus 3 minus 6?
1.
1. What's 2i minus I plus 3I.
4.
4I. Hey, look. This is a complex number, this is a complex number, and this is a complex number. You've just added them together, and what do you get? 1 plus 4I. So is adding really straightforward? Yes. What about multiplying? About the same. What's 4I times 2? What's 4I times 3I? 12I squared. What is I squared? Negative 1. So what does this turn into? Negative 12 plus... What do I put first? The real part. Put the real part first. Oh, what about this one? What's 3 times 4? What's 3 times negative 2I? Negative. You're right. You said the right thing, and I wrote the total wrong thing. This is 20I. And what's this? Negative 10I squared. Combine those two, you get 12 minus, or 12 plus what? Combine these two right here. What do you get? 14I minus 10 times, which is, what's negative 10 times negative 1? So you have 14I plus 10. Can you combine these two things? What do you get? 22 plus? Done. Do the rules of math change? No, they don't. You're just given one new thing. The only new thing I've introduced today, the square root of negative 1, is called I. That's it. We're almost done, everybody. We're almost done. Kind of like how we don't like radicals in the denominator, we also don't like i's in the denominator. You can't because of the plus sign, Megan. You can't because of the plus sign. It's not multiplying. What do you think you're going to multiply? Oh, Sarah, what you said it. What do you multiply by? I over I. So you multiply these two, and what do you get? I plus I squared over I squared. No. I times I is? What is I squared? So what do you get on top? I minus 1 over negative 1. And you could write that as negative I plus 1. You multiply by the negative. So if you reverse the order, what does this become? 1 minus I. Are there lots of ways to simplify these? Yes, there's lots of ways. The last thing I want to make you aware of is the following. This is what's really important. Do not pack up. Just stop twitching. I'm going to take 1 more minute of your time. This is really important. These look like they're terrible, right? This is what I want to show you. This is what I want to show you. What's I to the first power? That's I. What's I squared? Well, we know I cubed is I squared times I, right? Well, that's, what is I squared? Times negative 1. So what is that? Negative I. What's I to the fourth? Well, that's I squared times I squared. That's equal to negative 1 times negative 1, which is 1. What is I to the fifth? Well, that's I times I to the fourth, right?
Yeah.
So that's I times 1, which is? No, it's I.
Oh, I, because...
So let's look at what happened here, everybody. Let's look at what happened. I, negative 1, negative I, 1. Guess what's going to start happening? It's going to repeat. You see this 4 patterned right here? It just keeps on repeating, right? It keeps on repeating.
Yeah.
Good luck with the homework tonight. Get out of here.